to everybody across the fruited states and plains. It is 5 o'clock in Denver, 7 o'clock on the East Coast, and 4 o'clock in California. And it is time to start HydroniX Talk. This talk is a presentation of the Radiant Professionals Alliance. I am your host, Mark Etherton, also the current Executive Director of the Radiant Professionals Alliance. I have been a member for the last 20 years. I'm also a contributing editor to Contractor Magazine, and also a former expert witness. I got tired of working with lawyers, and now I'm surrounded by good lawyers. I'm also a licensed master plumber in the state of Colorado. Quickly want to go over some rules of the road. If you would please use headphones with a boom mic if possible, and that way if you have a question I can enable your microphone and you can speak to us directly without creating any feedback that would blow the eardrums off of anybody listening. If you would like, as an alternative, you can enter a question in a typing box into the Q&A text box, and I will receive that, and then I will interrupt our presenter and ask him to address that question. If you want, you can hold the presentation or the questions until the very end and ask them then. We have a Q&A session that follows up immediately after the show itself. And I would like to thank everyone for taking time to come in and attend this. Here's some examples of some non-radiant floors that I've been a big fan of over the years. This was a Habitat for Humanity house that we did about 20 years ago. And I had a co-sponsor in the National Renewable Energies Laboratory on this particular home. And they asked us to do radiant walls. We'd originally offered to do radiant floors, and they said, nah, that's too easy. We said, how about radiant ceilings? And they said, no, everybody has been doing radiant ceilings before they did radiant floors. And we said, we're running out of surfaces to radiate. And they said, you got it, we want walls. So we did walls in this house, and it was very successful. This house at one point in time held the highest energy rating of any house in the state of Colorado at the time that it was completed. I've spoken with the owner since then, and he's extremely comfortable. There's a picture of the radiant ceiling that I have at my house up in the mountains at a place called HydroniX, and it is interfaced into a solar thermal hot water heating system, as well as a modulating condensing boiler, as well as a ground source heat pump, as well as an air source heat pump, and eventually when I get time and find some space, I'll be able to connect my woody biomass sawdust boiler to the same system. My intent is to make this home a net zero home, so that when I retire up there, that I don't have to send all of my money to all the utilities. Here's the only commercial that you'll see during this show. We are a nonprofit organization. We would love for you to join us if you are not already a member. You can go to www.radiantpros.org and click on the join button. And there's a very quick and easy method of being able to enter your credit card number in there and get you signed up as a member so that we can all march forward together and let people know something that we've known forever, which is HydroniX is the most efficient system in the world. To give you a little bit of information about the talk show, this occurs once a month. We have guests that we bring in and interview on their products and their services. We have an open Q&A session immediately following the interview. All of these shows are archived for members only for review at a later date on the RPA website. These shows are meant to be fun, educational, entertaining, and oh, did I mention fun? If you have a person that you would like to submit as a guest interviewee, send them to me at mark.etherton@radiantpros.org. They do not have to be a member of the organization in order to participate on this show. We would prefer that they would be, but we realize that not everybody can be a member, and some people have products that are very interesting, so send them to me, and I will interview them and see if we can convince them to come aboard. Hydronic news that you can use. We still have all of the classes that we're offering available at the RPA University. The heat spring courses that they have up there. Basically, Heat Spring is our partner in this educational effort. We have the Radiant Basics course. We have an Advanced Radiant course. We have a Residential Hydronics course, which is being taught by Ray Wolfarth. And we have a Solar course. And we're open for any suggestions or instructors that might possibly be interested in providing us with additional courses that we can offer to our basic membership and allow them to continue to educate themselves. We have the AHR RPA Annual Education and Business Meeting, which is coming up on January 25th, 26th, and 27th in Orlando, Florida. During that same period of time, on the Tuesday, we will actually be having our annual social event, where we'll be wishing Dan Holohan a happy birthday and a happy retirement. His very last show that he is going to be doing live will be the PM Live program, which will be on that Tuesday, the 26th. And he gets over at 4:30, and our party starts at 6. And I would invite anybody that's interested in coming to meet Dan and John Siegenthaler and some of the other people that are members of the organization that will hopefully be there and be available to swing on by Tommy Bahamas. It is an RSVP required. So if you would please let us know here at the association, and we'll make sure that we've got a place for you to sit and some food for you to eat and some drinks for you to consume. We also have the Tom Grandy and Associates Planning for Profit program, which is slated in March. We're fine-tuning that date as we speak. For anybody that is a contractor in the business, I would guess that probably 90% of the people that are in business really don't know how to take care of business. And this course will show you exactly what you need to know. You'll be able to know what your hourly cost of doing business is, where your break-even point is, and how to build profits and the ability to be able to sell these programs to these customers without them asking questions. Real quick, a little legal disclaimer here. The graphics and illustration used in this webinar are presented for educational purposes only. RPA-IAPMO does not endorse or recommend the vendor, product depicted, nor any vendor or products. RPA-IAPMO makes no representation, warranties, or guarantees as to and assumes no responsibility for the products depicted. And RPA-IAPMO expressly disclaims all liability for damages of any kind arising out of the use of performance of the vendor's products or services depicted. One of these days, I'm going to be able to say that in one full breath. Our guest today is Dean Newberry. Dean, welcome.
Thank you. Thanks, Mark. You ready for me to roll with this now?
I am. Tell us a little bit about yourself and go ahead and take over the control. I'm going to pass the ball of power to you as we speak.
Okay.
And you should now be able to go ahead and take over the controls and drive us crazy.
All right. I have the presenter icon here. So there's my little opening slide. We're going to focus on radiant cooling today, hydronic radiant cooling. And my company is Talbott Solar and Radiant Homes, Inc. Bit of a long moniker, but it seems to work okay. And who am I? In the 60s, I dodged the draft and joined the Army, wound up in general cryptographic repair, learned about systems, working with people, codes and standards. It was actually a really wonderful experience and kept me out of slogging through the mud in Vietnam, which was really the purpose of my whole volunteering there. When I got out, went back to school. A graduate group that sort of drafted me was putting together an energy conservation building code that rolled up into Title 24 and other energy conservation building codes. It's a monster today, but we did the first one here at Davis. Out of that whole process, I began teaching passive solar classes and inspired some of the people there to actually get into the solar business in the 1970s. We also did some work in solar hot water systems, primarily in ICS, integrated collector storage, systems we still use today. After Reagan got elected, after Jimmy Carter, tax credits went away, we started doing other things, went back into my electrical roots, and we started setting up battery electric systems with solar and generators, and also worked on hydronic heating systems for off-grid homes throughout Northern California. Eventually moved to Vermont, learned a lot more about hydronic and radiant systems, and then came back to Davis and finished up my degree with the environmental and economic benefits of geothermal heat pump systems. Went to water furnace and got certified and began putting in those kind of systems. That's a wonderful set of courses if you can get the IGSPA course or water furnace or other geothermal heat pump vendors have excellent courses in their products and in our field. In the 2000s, last 13 years or so, we've been doing grid tie, solar with batteries, off-grid systems, hybrid, on-grid, off-grid systems. And in 2005, we really focused in on radiant cooling. So that's where we kind of pick up here. My company, Talbott Solar and Radiant Homes, Inc., we do residential, light commercial, photovoltaic systems, radiant heating and cooling systems. We do hybrid, passive, and active systems as well. Those are working pretty well, and in those, we've learned computerized controls utilizing forecasting so that we can look at tomorrow's energy requirements, how hot's it going to be, how windy is it going to be, and then use night sky cooling, off-peak chilling, etc., to collect energy that we'll use the following day. So we're using a one-day forecasting. Going to talk about that for several hours if anybody is interested. In 2005, we developed the Xlath self-furring radiant fin, basically starting with the panels that Mark used in the habitat houses. We used the same panels in habitat houses here, doing the same kinds of things. What we did initially was we just Tech screwed Z-bar onto the edges to get a self-furring panel, and then worked out a method to fabricate those with press brake and roll former for manufacturing. We're now manufacturing those panels, and we're offering limited supplies right now, but over the next 6 months, I expect to get into the market as you guys need panels. We'll have them available. So why are we doing this? What are we doing? Why are we not just out being plumbers and building custom homes and stuff like that? For me, it's been environment. I went to high school in India. When I came back, I went through the Army, got to see a bunch more of the world, realized it's a small place. Over the next few decades, realized it's the atmosphere. How can we restore our atmosphere and our environment in general, and improving our lifestyle at the same time? And then how do we do that? How do we use everything? How do we optimize everything that we use? In Mark's little lecture on his zero net energy cabin in the woods, he's really focusing in on how to do that. Really, the goal is, it's personal, how can we live economically, but socially, how can we have a place for our children and grandchildren to live? The inspiration came kind of in 2004 and 5. We realized that all of the PV panels that we were putting up in Sacramento region, during their main operating time in the summer, they're just operating air conditioners. When all the panels were going to Germany, I took a little sabbatical for a few months and tried to figure out how to reduce building energy directly. Through that research, reinforced my assumption that radiant panel systems can do that when we can figure out how to do cooling. Europeans have been developing those processes. The high temperature cooling and low temperature heating is a book that is informative on this. And Larry Drake at the RPA picked up on it. We changed the masthead from heating to heating and cooling and began to explore that. So how do we do it? Radiant floor systems have a wonderful reputation. You all know what that's about. And how can we achieve similar benefits in cooling? And then we'll explore the concept in the next few slides here. I'm hoping you all understand that heat moves in 3 ways. There's convection, conduction, and radiation. Heat exchange in buildings, convectors are baseboards, gravity furnaces, air conditioning, etc. Scorched air, we all know about it. Radiant-based systems are radiators, floors, and then ceilings. Looked into other people's work and what's the comfort equation? How does it balance out? And so this little image is to illustrate that radiation is a significant portion of our building comfort, and convection is 30%, evaporation is 20%. That's really to kind of address the notion that air conditioning doesn't really get us very far. It helps with evaporation because it's drying the air. It does the convection, but it really takes a long time to change the temperature of the surfaces by moving air. So part of the effectiveness and efficiency is shifting the surface temperature of the surfaces of the rooms directly. Hydronic radiant energy, this one is specific heat of water is higher than air, obviously. We can do low temperature heating and high temperature cooling. That's well known at this point. We have zero duct losses. Duct losses in California range from a low of probably 20% to much, much higher, because almost all ducted heating and cooling systems in California, at least, are failing in major ways. I don't need to go into why, just that they are. With radiant panel systems, we get back losses which tend to run less than 5%. Fan energy, quarter horsepower blower is 250 watts, 25th horsepower circulator in 008 or 9, 40 to 50 watts. It's the duct losses and the fan energy are the main components of the energy savings. So this is a house that we did several years ago. Title 24 passed, -30 when we switched from air to radiant, and the house operates pretty well. The upstairs west-facing bedrooms, west-facing windows, get a little warm in the summertime. The rest of the house is just fine. Historical perspectives, we'll skip through this pretty quick. And I think that's just a list of the slides. So we have depicted here Cappadocia, Turkey, very nice cave dwellings throughout central Turkey, good for both heating and cooling. They've been continuously occupied for, as I understand it, for over 6,000 years, maybe a lot longer than that.
Is that where Osama bin Laden was hanging out?
No, he was in the Swat Valley in Pakistan.
Okay. Looks like something he'd be living in.
Yeah, but no, this is a wonderful tourist trap, actually. The people here are great. If you, I lived in Turkey for a year and never got there. Turns out I was on 12 and 12, 7 days a week for that year and didn't get to do any tourist work, but was always enchanted with this. Friends of mine that have been there said it's really wonderful. It's a long trek out there from Ankara, but there are hotels carved into the rock. It's a pretty interesting place to visit. Highly recommend it to anybody.
Cool place to live.
Yeah, that's exactly. We got started when I was consulting with the guys at UC Davis that developed what became Title 24. We brought in Harold Hay to help us understand how to do buildings that don't need the heating and cooling for Sacramento area. This house is actually built in the Atascadero near Stanford, but it's inland enough so that it's not in the coastal zone. You can tell that by the wonderful planting in the front yard there. He used roof pond and movable insulation. We did several houses, maybe as many as 100 along these lines, but really developed passive solar systems as a result of the consulting and development work that we did at a company called Living Systems with Harold Hay kicking us off, and Lauren Neubauer from the Ag Engineering Department really dragging us along. Dick Bourne was one of the founders of the RPA. This is his house in 1986. It's a roof pond system with floating insulation. So basically, he put down B-deck, which is a standard commercial subfloor for steel subfloor in buildings, and then he put a vinyl liner in that, floated. I think there's only about 4 inches of water as a thermal mass, and then 6 inches of styrofoam. He runs a very large droplet, low flow sprinkler onto that styrofoam to create, to get the water out from underneath it. It drains back into the pond to cool the house in the summertime, and then in the wintertime, they leave the pump off and let the thermal gain from the windows warm up the building. Works really well. He's done many dozens of houses. I think everybody's concerned about water over their heads and mass high up in the building in earthquake country. I did help him a little bit on a border crossing station, I believe it's in Texas, that utilizes this as part of the welcome center in at the border there between Texas and Mexico. What we developed here, there was a culvert manufacturing plant in Davis, so we went over there and said this is a cheap way to make tanks. The houses, we did lots, maybe, I don't know, 50 or 60 of these houses in the 70s. And then we revisited the whole concept last year, but we put PEX coils inside the tanks and activated them. They work really well as radiators when we drive them, heat or cool. They can get most of the building comfort achieved through real passive methods for ventilating at night, and in the summertime closing it up, and then in the wintertime leaving the building closed up and letting the sunshine in the windows and heat up the tanks. So these tanks are 6 to 8 inches in from south-facing glass with an overhang that really sets up the passive solar space. So they don't see any sunshine in the summer. They see lots in the winter.
Do you have to do anything in the way of algae control on those tanks?
No, they're galvanized corrugated steel, and they're capped off with a little conical sheet metal, so we don't treat them. We don't do anything. There have been a few of them have been abandoned, and basically they just took a jackhammer and busted them out, and the water ran out into the yard, and they were done. So nope, no sunlight, no algae. When they use the fiberglass tanks, then they do treat that, but on these we haven't. Let's move on. I'm going to just do a quick survey here. Caro Systems from Becca is capillary tube mat. I've talked to the gentleman that owns that company. I like him a lot. I think it just doesn't fit very well with contemporary American construction, with drywall construction. So he's having a hard time getting much market share, but he really understands how this all works in a really good way. There's good information on their website. Runtal, big radiator company, they have been active in promoting radiant cooling as well as heating, and so we're showing them. The Masana does a sheetrock covered styrofoam panel with tubing and emitter plates embedded in it. We're actually collaborating on some tests in Stockton, California with utility companies, NREL, and the Energy Commission. Masana's got a room, and Xlath has some other rooms. So Masana's good. They understand this in depth. They've done about 50,000 houses around the world, are doing some fairly large residential, multifamily residential places in China right now.
Do you know Dale Chavez with them?
I don't know him.
He's a local guy, used to work for Warmboard.
Yep. And so this is our product. It's 16 inches wide by X long. So it fits into the building frame layout. It generally runs perpendicular to your joists, so we don't care what that layout is. It's a self-furring plate, installs like a resilient channel. We prefer to have sheet rockers install it because you tell them to put it up like RC channel, and they just go. Where it was taking carpenters a day, 2 carpenters a day to put up panels, sheetrockers will do the whole house the next day when they come in. What happened is they came through on a pre-site walkthrough, saw what we're doing, offered us a bid, contractor accepted it, they were done. It was just wonderful. So, hooray, sheetrockers, we love you guys. Yeah, that's right. They know their shit, and they do it better than everybody else. Don't try and have your plumbers do this. It's a waste of money and very frustrating. Have the plumbers come back and snap the tubing in. They will race to keep up with the sheetrockers. We did get a patent on our panel, which really establishes the self-furring method and the way we do that.
Congratulations on that.
Thank you. Yeah, that was 5 years to get that. And then early unit, this one is with, this is the Green Residence in Napa Valley. They're very happy. It works really well. I get perfect referrals from them. The house has been running now for 6 years or more. Those are early panels fabricated from on-dole panels from Quiet Side and with the Z-bar on them. That we picked up a container of those at some point. And so there's several houses as we were figuring this out done that way. The shiny bits are the foil tape over the tubing.
Did you say on-dole?
On-dole panels, yep.
On-dole, that's the early Korean radiant floor heating systems, isn't it?
Yes. So I just bought the metal sheets that go onto their integrated panels and just had them sell me a whole container of them.
Wow.
I have a really wonderful relationship with Quiet Side, so I love those guys. They've gone through some struggles, but they're really, really strongly support our industry. And I think all of the QVM9s that we've put in since 2004 are still working. Open them up now, and they look pretty nasty inside, but they're operating. So pretty happy with that company. This is the first house with the real Xlath panel, the new panel with our design specification. This is the Gold Residence in Carmel. This was designed by David Knight at the National Radiant Design Center in Monterey, and it helped them get through an issue with massing in the house and no place to put ductwork and the way they were doing floors. It was the right solution for the time for them. And Mr. Gold he's a wonderful, crazy character. I love working with him. So what does Xlath do? It's an integrated panel, provides space for the tubing. It's designed for radiant heating and cooling, specifically designed for cooling. The labor to install the panel is about the same as Resilient Channel, plus the work of snapping in the tubing. Tubing goes in pretty quick, but you will have sore shoulders at the end of the day. We've set the tube groove up very tight so that it's really grabbing the tubing, makes it a bit of work to massage it in.
It's a good bite, huh?
It's a good bite, yep.
Have you ever seen the pneumatic, actually it's a palm nailer that Dale up at Solar Engineering developed that's actually got like a plastic nose piece that fits perfectly under the tubing, and you can just zip right along with that thing.
I like it. We'll have to get some.
Yeah, check it out. It's pretty neat.
Okay. We're designed to be part of a dedicated outdoor air system. That sentence is to help you orient to what we're doing. And so in multifamily, it replaces the fan coil in each unit. It uses a similar room temperature detector. Basically, we can use the same thermostats. Some of the thermostats catch the air temperature are not so good on the radiant temperature. Nest is actually quite good. The Honeywell IAQs are quite good. There's some others. We're looking for the temperature sensor that's kind of near the edge of the case so that it can interact with the radiant environment more in the air, moving up and down the wall less. We use the same valves, controls, etc. as you would for heating. It's really, boy, we use the toolbox for radiant heating, and we don't do a lot with it, but you know, we wanted to. The whole point of this was what's the minimum inflection point? What's the minimum innovation to get from heating to cooling? And we think it's the integrated self-furring fin is the key place. Although I would have to say controls is also been evolving and getting a lot better. Tecmar has some wonderful solutions. They're a little complicated to implement, but we like what they do, and a lot of our customers use them. And I just insist on a lot of customer interaction when we do a Tecmar installation, so that they can service and maintain it pretty much on their own.
I know Siegenthaler put out a general call in an article he did within the last year, asking some control manufacturers to come out with an inexpensive dew point sensor.
Yep.
Which could be used in these types of applications, and that's the biggest thing. When I speak and teach, I talk about radiant cooling, and you can see the light bulb going off in their heads.
Yep.
And I say, no, the first question out of your mouth is going to be, what about the condensation? And they all nod their head. They go, yeah, that's right. That's what I'm worried about. What about the condensation?
Well, what we've done for a cheap fix on condensation is we use these Honeywell IAQ thermostats that have the humidistat in them. And when the humidity goes over 60%, we close the S1 contacts on that series of thermostats. Mm-hmm. And that implements our dehumidification method, which I think we'll get into on another slide here. So I think we'll move along, but we have been able to do not really a true dew point control, but at least a reset, simple two-step reset based on the relative humidity in the building.
Well, sure, there's a direct correlation between the humidity and the dew point, so you're controlling it. It's just a different way than most people would think.
Yep. Yeah, and I am an electrician, carpenter, not an engineer. So there's certain parts of the traditional education which I did not get. And most of the time it leaves me free to figure things out in a slightly different way and get a pretty good answer. Sometimes I'm just caught flat-footed.
Innovation.
Yep. So we hope to operate above the dew point. We want to prevent condensation. When we do that, we prevent fungi. It's non-flammable, and tubing and the HDPE and PEX is commonly used in new buildings. I was flipping through the new hydronic code and was pleased to see the HDPE got in there with PEX because that's on these kind of systems. We're low temperature heating, and HDPE makes a lot of sense, and it's much easier to manipulate into the panels over your head than the PEX. So building structural issues, the reason for bringing in building structural is if you don't have to fur down the ceilings, if you don't have to create space in the building, if you don't have to insulate the rafters, you can save money, and you may wind up bringing a radiant panel system designed correctly in cheaper than a ducted system with modern energy codes and standards. So it takes less building volume than ducts. That's important to some architects, not to others. It installs using standard building construction trades-in practices. I should add trades in there. We like to see the lathing installed by the drywall contractors, tubing by the piping contractors. Connection using the same method as a fan coil. Basically, we connect onto conventional manifolds. We've used the plastic manifolds that you might see for modern hot water and cold water distribution. We've used the copper tube manifolds from all different kind of manufacturers. and of course all the good manifolds that have the circuit setters and all of that. So we don't really care, although as we're figuring stuff out, I really like to have the circuit setters and the gauges on the manifolds to see what's going on. And we add negligible mass, good for our structural engineering types. Let's see if I can hit the button. There we go. On energy, pumping losses are lower, low temperature heating, high temperature cooling. Again. There's less infiltration without pumping the air. That's actually a bigger deal than you might think. If you have tears in your ductwork on the supply side, then you'll be drawing unconditioned air into the building. If you have a bad return air system, you'll be blowing air out of the building. So we leave the building kind of neutral with a hydronic radiant system. And so we know that under operating conditions that we're using a lot less infiltration. Then the last bullet is for, we looked at doing radiant heating and cooling on a hotel up in South Shore, Lake Tahoe, where it's very cold. And they do not require any heating, only cooling. The surface to volume of the building is such that the insulation and windows is good. They do condition the fresh air that they're pumping through the building, but they do need additional cooling year-round. And they went through some financial trouble, so we didn't get a project, but we certainly did explore it at length. Risk management issues, mold, smoke, and aerosol distribution in when things are burning. So there's probably other risk management issues that we could add to that. That's just a first draft of that particular issue, although it's a big deal for bankers, developers, and people who are doing multiple housing. The environmental benefits, we like the HDPE because it recycles. The coated steel that we're using recycles. There's less energy overall, and the smaller building volume uses less material. What I've learned in manufacturing is it's pretty much what do you want? Steel weighs X and it costs Y, and your price is 2.5 times Y. Make whatever you want. And so manufacturing uses rules of thumb similar to contracting. It's kind of interesting. We've deployed in now, that says 54, we're up to mid-60s now. 2 commercial buildings. SMUD's new center in South Sacramento uses the Xlath in the east and west zones of the building where they need faster reaction and stronger interaction than they can get with their concrete embedded tubing. And then the the Indigo Architecture building here in Davis. And there may be some others because we sold panels to different people and I don't know where they all landed up. Title 24 methods model the system. The setting in there that we need to watch out for is ducts. Have the Title 24 or Energy Pro guys set the ducts inside the insulated space, ducts and conditioned space, and they'll get a pretty good model of a radiant panel system. The dedicated outdoor air systems, the guy in Philadelphia or Pennsylvania has done a lot of publishing on DOAS. I think other people are picking that up as well. ASHRAE and RPA now support radiant panel cooling systems. Apple's new headquarters is Radiant Ceiling Cooling. The King's Arena in Sacramento is. The new Caltrans building up in Yuba City is. There's lots of others. I think a lot of the new signature energy buildings around the world are using radiant cooling now on big buildings, just in the last 10 years.
The National Renewable Energies Laboratories,
yep.
what do they call it? Their field research support facility building in Golden, Colorado is done with radiant cooling. It was actually a site that the ASHRAE folks were on tour for a couple of years ago, and they had their program here in Denver, and it's working beyond anybody's expectations. Talk to the people in there, and like, this is the most comfortable building I've ever been in.
Yeah. Oh, yeah. The other one that you might get to visit at some point is the Bellagio in Las Vegas, is Radiant Ceiling Cooling Systems. We did a big house, 8,000 square foot house here in Davis, lots of east and west glass. We can hold that house at 68 when it's over 100 outside. And then we have another one that's a little 1,600 square foot tract house in Sacramento. Again, we can hold that one to 68. So
68 would be cold, wouldn't it?
68 would be cold, yes. He operates it at 71, but when the developer was building the house, it was a spec house, he was yelling and screaming and worried about this. And I said, just set the damn thermostat where you want it and let me know how it works. So he just jammed it till it quit going down and walked away. And 2 weeks later, I hadn't heard from him. So I kind of went by the job site. They were putting in towel bars and electricians were putting in fixtures. And said, asked the windows, the doors were open, the whole house ventilator hadn't been put in. And I asked the electrician how it felt, and he said, this house is cool. And the thermostat was on 68, and I said, okay, good enough. So, and then moving on, Western Cooling Efficiency Center and Davis Energy Group, PG&E, and NREL, and Energy Commission are all studying systems utilizing Xlath and Mesana systems. So we're starting to build some papers around these concepts, and I think engineers and architects are in a place now where they can start to get much more comfortable in this stuff than they would have been when we started this 10 years ago.
You know, they're starting to see the results of some of these programs where they've actually applied them, and they're seeing reductions in energy consumption of 50% per square foot.
Right.
That will get your attention, and occupants that are actually more comfortable than they've ever been before. It's like, we've been trying to tell you this for a long time.
So there it is. It's invisible, it's quiet, it provides better health and better comfort. Why would you not do this?
Cost.
Nah, not anymore.
I know. I just thought I'd throw that in there so that you could address it, because I know you have.
Okay, that's right. We've been strongly focused on making systems simple and effective, and that little 1,600 square foot house in Sacramento, the bid for forced air was $5,600, and I said, okay, we'll do it. And let's go through. There's some slides coming up. I'll show you what we did as we modeled that house. We built it on the model, and so we'll see that slide in a little bit, and we'll talk about that again. So tubing and manifolds, manifold box. This is just some of the mechanical stuff. So here is a closet wall between the kids' closet, bedroom 2, and the hall bath. We stuck the manifold in there and brought our tubing up through the wall. Copper tube manifold. We just boxed it out with a sheetrock and put a return air grill over it, so that if there was any condensation or seepage, it'd have a chance to dry out. That's working fine. The mechanical for that building, the pumping, purge and fill, controls, you can see the little Ranco control. I don't know, is my mouse moving over where you can see it? Or not?
Not on my screen, no.
Not on your screen. So there's on the right of the Tetco SR501 is I think it's a Ranco or maybe a Honeywell Aquastat. That's my cooling limit switch. I think it's set for 61 on the supply, so we stay off of the dew point. That's just in a closet next to the chiller. But you can see it's very compact, and it gets covered with a return air grill. Here's one we're actually working on today. So this one we used a buffer tank and an AirMech hydronic heat pump. So we're pumping with one of the pumps into the tank and then out of the tank with the pump that's kind of centered on the tank into the manifolds. We have a little flat plate heat exchanger for the making hot water. So the hot water circulator is on the right. The primary circulator is going into that three-way valve behind the flat plate, and then we're coming out through Watts manifolds. Purge and fill is right there. The whole thing is over a sheet metal drain pan and drained out, all code compliant. Everything will get insulation. You can see all the pipe is in insulation bushings strapped on the calcite insulation bushings, and then we'll install the fiberglass or Armaflex insulation as we begin to wrap this project up. They're laying down the radiant panels today.
Is this in an attic?
It's in an attic, yep. It's an old package forced air system, and we just moved the drain pan over where we needed it, tore out the air, and we put a water heater drain pan under it, tied all the drains together. So, yep, it's in an attic. It's a high pitch, and it gave us lots of room to work. We did put in a ladder access so we can get up there easily if we need to, and we put a big fluorescent light fixture so we can see what's going on. But this is costs a little bit more than replacing the entire furnace and duct system. I think the bid from Butler was around $22,000 to rebuild the air system, and ours was about $26,000 to do it this way. And we're vacuuming out all the insulation, laying radiant panel down on top of the sheetrock, and then blowing the insulation back in on top of it. And it just for a little extra benefit, we're going to put in some of the bubble foil TVM 30848 or other similar product right on top of our radiant panels to help the insulation out a little bit. This is another boiler board. This uses a QVM9, a quiet side combi boiler, with a cooling tower chiller on the right. So the compressor's in the box on the right. The cooling tower is the vented cabinet there. On the left is the QVM9. There's several pumps there because we have a primary circulator for the radiant. We do a injection, primary secondary injection to the chiller, and then we do another primary secondary injection for the wine cave in the house. And then there's a little water treatment equipment there on the right. And then we're using the Tetco SR503 or 4 to probably SR503 to control the pumps. Give us some relays for that.
Is that cooling tower wet or dry?
It's wet. It's a real cooling tower. It's a 5-ton unit. Yeah, Mac Ward at Thermal Flow makes those in Austin. And they're reasonable, and he's wonderful to work with, knows this business like crazy, knows refrigeration and alternative energy cooling like nobody I've ever met. Mac is wonderful. So buy some of his cooling tower-based stuff, start the conversation. We use him as a resource for refrigeration technology all the time. Wonderful guy. So there's a list of other stuff. So this one is a crazy system. We've got a what's the geothermal heat pump guys in Texas? Climate Master unit, water-to-water unit on the right, boiler board above it, electric water heater that also runs off the Climate Master, and then we did half the house because a big room addition radiant. We left the old part of the house fan coil, so we needed a little more heating energy. So we put the QVM9 in there to boost that up a little bit. So we've got 2.5 tons of geothermal heat pump loops out down the hill to the right. and then we boost up a little bit with the combi boiler in the summertime. But that house looks great. When there was big fires up in the Grass Valley area and people needed to stay indoors, everybody gathered at that house to play pinochle because it was really comfortable and it wasn't blowing the air around. So
I'm glad to see I'm not the only one that's been able to put 5 pounds of sugar in a 2-pound bag too.
That's right. Yeah, this is kind of my test bench up there. I've learned a lot on this particular house. This is the first one we did. We used a Tetco geothermal heat pump. We make hot water with it. Radiant. We didn't kind of know what we were going to get, so we did radiant floor and ceiling. We just kind of wrapped it. Works really well. This does have a problem with the upstairs west-facing bedrooms, and they just put up curtains and live with it.
Fenestration.
But this house was built by a physics teacher who got laid off during construction, moved to Oregon, put the house on the market. It was the first one, and I said, "Who's going to buy this crazy radiant house?" Lady called in January, said, "Can you come turn it on?" and I said, "Why?" After it warmed up, I said, "Why did you buy this house? There's nothing like it." She said, "Oh, my dad's a radiant contractor." He said, "It'll be fine, don't worry." So she grew up in Idaho. So there you go. It only takes one buyer to move a house.
Yeah.
And we found the right one. This is one of the sweetest little chillers we built. It's a Ream 2-ton with a 2.5-ton flat plate, refrigerant to water heat exchanger tucked in the corner. We like the old Ream chassis because there's room to work with, and the compressor's outside the coil. So we got a little Ranco. That's our chilled water shutoff. We set that again for about 61 with a 5 degree. So it'll drop down 5 below 61 and cycle there, and that's working really well on that house. There's 2 houses like that in Oceanside, California. Wouldn't think you'd need much cooling, but they get pretty good glazing gains, pretty much in pretty good insulation in there, which we're cooling out. This is one of the early ones. We took a York heat pump and stuck a flat plate on the outside of it, insulated that. We've had no issues with that. That thing's been working now since 10 years. And it just works. That's the
single stage or 2-stage compressor?
Single stage. And that's the house that had the copper tube manifold in the bathroom wall that we saw. And then right behind that disconnect on the left of the chiller is that little tiny pump station with the 2 purge and fill valves all wrapped into a little tiny 16-inch wall section.
Okay.
So, yep, that's been fabulous. On this system, this is one of the habitat systems that we did. QVM9, the chiller's outside the wall. We have no valves in this system. We circulate the heating water in the heating season through the chiller, but we don't activate the chiller. So the QVM9, the chiller's on the return line. The QVM9 primary, secondary injects hot water into the system, comes back warm, passes through the chiller on its way back. So we're able to build these systems with 1 pump, no valves. We just use controls and primary, secondary designs to make them simple and reliable. These houses have been operating now 10 years. They're about to come off warranty.
The KISS principle, right? Keep it
yes,
sweet and simple.
Yes. It's extremely difficult to do. Every mechanic that the drywall guys that install the panels, the plumbers that install the tubing, the plumber that goes to install the equipment, everybody keeps trying to make it more complicated than it needs to be. Really have to keep focusing those guys on make it really, really, really simple. Yeah. The only thing I would say is buy an $8 hose bib instead of a $3 hose bib, because the hose bib washer tends to stay better in the $8 valve. This is what happens when we're building a radiant panel system and they're sheetrocking. We hook it up to a hose and bring it up to line pressure, and we can tell when it's screwed. And there it is. That's what happens. In this case, we were running the panel parallel to the joist and too close to the joist line, and the sheetrocker drifted off the joist a little bit and hit it 5 times. He was still there. We ripped down the sheetrock, spliced in the pipe. He put up another piece of sheetrock. It was all repaired and done in about 45 minutes, and everybody moved on. It was a wonderful experience, actually, to show what happens. This is one of 3 habitat houses that we did. They also got somebody to donate the PV. Pretty nice little houses. This is the Green Residence in Napa Valley. Beautiful place. The Gold Residence up in Carmel. Even more beautiful place. Okay, pretty quick. What's the design process? Really simple. Get the plans from whoever, architects, engineers, homeowners. Do your manual J loads. I use WriteSoft, and you can see this is a screenshot where I opened up the room and the duct loads for the room, and I set it for conditioned space. That's the setting for Radiant design. It's really simple. Same for Title 24 and any other program you might use. Just get rid of the duct losses, and you're as close as you need to be for a Radiant design. Use the loads report, print it off of that. So at the bottom there is the square feet, the heating load, the cooling load. I use the cooling load, and in this case, the living room load is 2478. We divide it by 15 BTU per square foot per hour, and we get 165 square feet of Xlath, which is most of that ceiling. I think this is my house, actually, which is it's old. It's got a lot of glass, not much insulation. However, we designed like this, and it works pretty well. The output of the Xlath in cooling is actually closer to 18 BTU per square foot per hour. We use 15 so that we have some fudge factor. And then we recommend using a dehumidification machine. If it's a fan coil, size it for the latent loads. I'm going to go back a couple of slides here. One slide. So the latent in this is 1,200, half ton. No, 1,200. It's nothing. It's very little. However, I'll use probably a 1-ton coil on this because I found that a little bit of warm air or cool air really helps with the comfort on a building. Size the fan coil for latent loads. However, in Sacramento, you're not going to find any equipment that's small. So use the smallest you can get and run the fan slow. We set the fan coil in series with the Radiant panel. So you go from the chiller, pass through the fan coil, and then go to the manifold. In most cases, we use a pair of Venturi tees to divert only a portion of the water through the fan coil because we don't want to choke it down too much. That's how we've done that. You can distribute with high velocity or small zone. A lot of times we just do a closet pack, which is a pretty common fan coil. First Company and lots of others make them, and then we just duct out into the adjacent rooms and pull in from the room that the unit's in. And sometimes we'll use 2, but that's worked pretty well. And then we set the chilled water aquastat between the fan coil and Radiant panel, which guarantees that the chilled water will be on the closer to the dew point or below the dew point on the fan coil and above it going to the Radiant panel. In some places we use dedicated dehumidifiers. On one house we used the kind of geothermal heat pumps, and we put the geo coil on the return side. And so we just felt like we needed a little more backup on that building. As it turns out, the radiant is working so well that very seldom do the fan coils or the air handling heat pumps come on to help us out. Here's real simple radiant. This is no reset, but we start out in the reversing chiller, pump away, just like Radiant Basics would tell you. Go through the fan coil. Normally that's a pair of Venturi tees, so you don't choke it off too much. Set your aquastat between there and the radiant panel. Come back into your chiller. The K1 relay basically allows the aquastat 58-degree set point to be in the circuit in the cooling mode, and we short that so that it's not operative in the heating mode, because the system's going to get below 58, and we don't want it to lock out on us. So that's one of my real simple radiant designs that illustrates the previous text. Okay, see if we can move to the next one here. Pumping and piping generally follow Radiant Basics by Siegenthaler. RPA has the Radiant Basics manual that he did. That's the Bible that I use. However, in cooling, we have found a problem, and it's the Reynolds number. So that's what this second paragraph is in cooling, in order to achieve a good heat exchange rate between the hydronic fluid and the walls of the pipe, velocity will be higher. And why is that? What's going on? It's the Reynolds number, which is something that they taught us in water furnace school. So in heating, and you're all familiar with this, at roughly 120 degrees on a radiant floor circuit, about a half a GPM for half-inch PEX is sufficient to make it work. And the velocity is 0.9 feet per second. The Reynolds number is 7802 on the Hydronic Design Studio. And so I'm just using that as my software for figuring this out. For cooling, if I just, in Hydronic Design Studio, if I change the temperature from 120 to 60 and maintain half a gallon a minute for half-inch PEX, velocity is still 0.9, but the Reynolds number is 3888. It's half. The Reynolds number is half at 60 degrees that it is at 120 degrees. What's going on there? And let's see if I got it in this next slide. Yeah, in hot water, the molecules are more energetic and will interact with the pipe at low velocities. In cool water, the molecules are moving slower, and therefore more velocity is required to increase the turbulence to force interaction with the pipe. So what's driving this is we had some failures, including my house, in exchanging heat. The chilled water would go right down and start sweating on the pipe, but the delta T was a degree or so. It was like not working. And then when we added a second pump, I think that's the next thing is, what do you do about that? Add a second pump. So the chiller manufacturers recommend a buffer tank, one pump to the chiller, one pump to the load. That works. Geothermal manufacturers use push-pull because they already have the mass through the geo side. So here's push-pull pumping. So this is what solved the problem on my house and the ones down in Oceanside. Is we just added a second pump at the chiller as a convenient place to do it, and now we're pumping away with the pump on the right from the chiller, go past our fan coil into the radiant panel, and then pulling away from the radiant panel and pushing into the chiller. The hydronic resistances are primarily the radiant panel and the chiller, and so by push-pull pumping, we split that hydronic resistance in half, and we get back to the roughly 8,000 Reynolds number that we need.
And that brought your numbers up?
Yeah, it did. The house just clicked right in, went, the one in Oceanside went right to 68, and stayed there. It wasn't that hot out, but we were still getting high solar gains. And so the developer was very happy with that. This is that same drawing, twisted around as fast as I could to make it into a buffer tank drawing. Chiller to the buffer tank to the load. Achieves the same results, but it adds the mass of the buffer tank, which is what the chiller manufacturers recommend. So, okay, you guys want that? We'll do it. I wish buffer tanks didn't cost so much, but they do. Watch out, we're using non-barrier PEX in the house we're doing with the attic system, and they shipped a boiler buddy, which is an iron tank. So we put that back in the shop, and we bought a water heater, which we refitted into a buffer tank, is what you saw in a previous slide. So we're setting up several different projects like this, and we've done several the other way. And we expect them all to work pretty well. So here's the Hydronic Design Studio circuit simulator at 60 degrees Fahrenheit. Kind of in the upper middle there is the fluid supply temperature. We picked a Tetco 008, 1-inch common piping and manifolds, half-inch PEX. I think it was, I picked up 250 feet, kind of short loops, but not real short. And we're getting 0.97 GPM with that design. And what's going on is if we add a chiller resistance in there, the GPM goes to 0.5. So we really need to push and pull or put in a buffer tank. And then we kind of get back to we get the design parameters we need. So we really need to I can't emphasize enough, you need to make sure that your Reynolds number is high enough so that you're exchanging heat between the water, tube, and fin.
That Reynolds number is a strange number because it's dimensionless, but it does, in certain situations, make a big difference.
It makes a huge difference. So here we are looking at Hydronics Design Studio in their pipe size. And so here we've selected PEX 0.97 GPM, which is what we got on the previous slide. Minimum is 3/8. If you look at the half-inch number, we're 1.7 feet per second. And our Reynolds number there at the bottom is 7,500, a little bit more. So that'll work. That'll work. So the Hydronics Design Studio is, I use it all the time. It's another Siegenthaler product you can get off of his website. I think that's it. I'll take questions. Or you want me, Mark, I'll let you take over and move it through to the next.
Yeah, if you would drag that ball back over to my name and drop it. And we actually do have a question. One of our
Where is that ball? Tell me.
Oh, wait a minute. Never mind. I've got it. I'll do it.
Okay.
One of our listeners is Mike Ginsberg.
Oh, hi, Mike.
Mike, do you know Mike?
Nope. Maybe.
Mike actually has some experience with radiant cooling, and I am going to, somebody can figure out where he's at, enable his microphone. Michael, you're live. Careful what you say about me. Mike Ginsberg?
Can you hear me?
We can hear you.
Yeah, Mike. Hi.
You can hear me?
Absolutely. Clear as a bell.
Wow, that's cool. Hi. Sorry, 1 second. I'm a home builder in Tucson, Arizona, but mostly just kind of do stuff myself.
Yep.
Did a radiant heating and cooling house a couple of years ago. It was monitored by Davis Energy Group, so it's nice to see that you're working with them there also. Dave Springer's a pretty good acquaintance of mine in that regard.
Okay.
As a layperson, is it really radiant? I mean, the radiant radiant elements are heating the air that's heating the space or conditioning the space, and then we feel it. I mean, it's not like the sun. I know this is a basic, silly question, but I just need to get it clarified in my head. It's not like the sun where you stand in the sun radiates and you feel warm. You get behind a tree and you don't feel that.
No, it's exactly that.
It's exactly that. It's not heating the air molecules.
Nope.
Pardon me?
Ooh, heating you directly.
At 186,000 miles a second.
Yeah.
It
Well,
affects what we call the mean radiant temperature, which is the surface temperature surrounding your body, which is the primary dictator of human comfort. And you're right.
Okay, and
that's something people don't pick up on.
Yeah, but the surface temperature around our body is a function of the air, is it not?
No.
Okay.
No, the air is influenced by the surface temperatures indirectly, but the mean radiant temperature is the primary dictator of human comfort. That's why you can be comfortable outside on a cold day standing in the sun, because your body senses that higher MRT, and it doesn't really care what the air temperature is doing. You're comfortable.
Yeah. The house in Napa Valley has big sliding glass doors on the east and west. They're well shaded, but when it's over 100, they set the house for 78, for the radiant temperature, and they leave the doors open so the fresh breeze can blow through the house, and it doesn't really change the comfort or the temperature of the building.
I still have a difficult time comprehending that, and I'm not asking for an educational thing.
If you've ever stood around a campfire, you know exactly how it feels. That's it.
Yes, I just don't get how that works in my house here with the radiant cooling and the radiant heating.
Radiant heated. Radiant heating is just a large surface area at a low temperature, but it's exactly like a wood stove or a fire. Just larger area, lower temperature. So if you have something that's small and hot, like a wood stove, then it radiates to the other surfaces which come up to that temperature. With a hydronic-based system, we just raise the temperature of those surfaces by circulating hydronic fluid, water, through behind those surfaces, basically, to warm them up.
Okay. I started to get that a moment ago. So in my house, for example, I use the entire concrete floor of the house for my radiant system for heating and cooling.
Yep.
And it just, I do temperature readings at the floor, touching it, a foot above, 5 feet above, 10 feet above. And in the wintertime, of course, there's no stratification because, the heat source is at the floor.
Right.
So it's the same temperature everywhere, not only vertically but horizontally, because the whole house is radiated.
Yeah.
But in cooling, the floor is chilled. The surface floor is, let's say, 70 degrees in the summer when we're 110.
Yeah.
And the airspace above is 4 degrees more.
Yep.
Mm-hmm.
Now, if I don't have my feet on the ground, if I'm sitting on a chair, that airspace is 74. And that floor is still surface is 70.
Yes.
So the coolness from that floor is just jumping to my body.
Your body is radiating to it. Your body is the warm body. Your body is the stove, and it's the cold night sky.
Well, that's funny that you said that, and I got a chuckle out of that because, that makes sense, obviously.
And you know what?
The heat from me, heat moves to equalize somewhere else.
Exactly.
From hot to cold.
Right. Maybe that's why I have a hard time getting it. At any rate, I guess I chose to sample that in the floor rather than panels on the walls or ceiling because of that water issue. And if I'm already radiating the floor, by finding a reverse cycle chiller, I'm able to chill the floor.
Right.
And so it was kind of an all-in-one thing. Now, I do have a forced air system also. It was mostly for dealing with the what-if scenario if it didn't work well and I needed additional cooling in the summer, which it turns out I don't.
Right.
But it was primarily for and solely for dehumidification that I would run it overnight.
Yep.
Or when it's running. Now, since I'm not, I have an ice chest-like house with proper solar orientation. I have no direct solar gain in the wintertime specifically because I have the whole house radiant floor and I didn't want the direct solar gain to upset the integrity of the system, and it works incredibly well. I only run the compressor in the wintertime during the day, nonstop for maybe 3 hours to recondition the floor, so to speak. And then the house sails for the next 24 hours.
Absolutely. Yeah.
And the same thing with the cooling.
Yep.
Why? I had a hard time. You mentioned, let me look at a note here.
Mike, while you're looking up that note, I'd like to mention something. A lot of people experience radiant cooling and don't even realize it. And I realize that you don't have a whole lot of basements below grade down there in the great southwestern desert. Anybody that has a basement during the summer months when they walk downstairs have felt the effect of the mean radiant temperature and radiant cooling and didn't even realize it.
Yes, and the analogy I use down here in talking with people, it's like a cave. We have the Desert Museum that has a cave, and it's just, you walk into a cave and it's cool, period. We have below grade parking garages, and it's pretty clear there. But the AirMac hydronic heat pump, the only reverse cycle chiller that I found that Dave told me about years ago, and we did this, was Aqua Products. Is there another one on the market?
There's more and more, actually. The AirMac, it's AIRMEC. We also use the Dakin Althermas. That's what I have in my house.
Yeah, too expensive. I priced them out at the time.
Yeah, and you saw that York heat pump that we converted. Those work too. But I learned all that from Dave.
And Aqua Products used to use York. The one they did use for me was for a ream.
Yeah.
And they just had their proprietary heat exchanger underneath the standard 2-ton ream unit.
Yep, those guys are great. The shipping is too much to get them out here.
But there's another one like that. There's more than one out there. Market's starting to develop from the work that we've been doing, from the mostly with the enthusiasm of the RPA and from the ASHRAE committees on this. And so the manufacturers are stepping up. Yeah, hydronic heat pump. Mike Erickson has got more and more products coming on. Good, because I had been concerned if no one down here has done what I've done. And there's no contractors or HVAC contractors or plumbing contractors that will really do anything. And the only reason with me is because I've known them for so many decades.
Right.
And, it's in the field. But when I go to sell this house with my partner next year, I have to be able to pass on to them the simplicity and the contractors that support redoing this. And if there's only one reverse cycle chiller out there, that I don't like that, but that's the way it is.
Yeah, now there's more product out there, and a good mechanical refrigeration guys that work on grocery stores, they will get this. So that's where to go find the right guy.
Okay, that work on grocery stores?
Mm-hmm.
Okay, I'll check that out.
Yep.
Let me I don't know what else. I could ask a lot of. I mean, this was my first foray into radiant anything. and it was an experiment that turned out extremely well, way beyond expectations. And
Yep.
Dave Springer was surprised. I did a lot of reports on it, but the simplicity of this house, the design stuff that mechanics that you were referring to in the I forget which one who has Single Leather, I think is his name, and some other.
Siegenthaler.
I don't. Maybe because I'm not an engineer, and probably so, but I see just the basic simplicity of this. I got tubes of 1 foot on center, and I have an air source reverse cycle chiller. What's, why all the complications? It depends on
your home's different.
The design of the house and all that kind of stuff.
You're in a super insulated home, and most houses are not super insulated homes, and a lot of the manufacturers, the bigger manufacturers, Uponor, Rayhow, Viga, have actually in Watts have developed radiant cooling programs for their tubes now. And so it is something that is commercially readily available to their dealers that they can apply this to. And not every house is a super insulated beer cooler like yours is. And in those scenarios.
Is that that's primarily the reason I get? I mean, because I have an ice chest, it's, I don't need the tubes at 6 on center or 9 on center. I just do the whole house at 12 on center.
Yep, exactly.
They've designed a real basic system, and I'm wondering about if I go to replicate this in low-income housing. I mean, how complicated can it be?
It can get more complicated. The bigger the load, the higher the density of tube required to be able to counter the demand.
The load, if I design the house and build a house so that the load is the same as this or similar, it's still going to be pretty simple, I would imagine.
It could be, but
I guess
you would want to go back to David to check anybody else's design. There
absolutely
lots of good mechanical engineers will not understand what's going on and make it too complicated.
I know. Yeah. And Dave
Radiant Design Center in Monterey, they're somewhere in between. Not too complicated, but not as simple as Dave Springer does them either.
Yeah,
I enjoyed this.
Thank you, Mike. And with any system, you've got to do the math.
Yeah,
it's important, and that has gotten more people into trouble from not doing the math and saying, well, I did 12 inches on center in this house, so we'll do that in this house. And if you have a big difference in loads, then all of a sudden you've got a customer that's complaining and telling 10 people who tell 10 people who tell 10 people, and the next thing you know, you've got an inverted pyramid of blame pointing at Radiant saying it doesn't work, when in reality it would.
The thing you said there was the load.
Yes.
The load is being the determinant factor.
Yeah, and there's a lot to radiant cooling.
Absolutely get that. I don't build much. Every once in a while I'll do a house like this every 5 or 10 years or so. So I'm not a production builder that need to hire all these outside engineers and stuff like that and try and hope that they're doing the right thing, or they just overloading the design because they're protecting their ass kind of thing.
Yeah, and that's not necessary.
You're right. They oversize terribly, typically. It's always been that way, unfortunately.
And that's driven the cost up, too. And that's one of our goals. With Dean having this radiant ceiling system, we don't have to cover every square foot of the floor with 1 linear foot of pipe, because we're not selling anybody on the concept of warm floors or cold floors. We're selling people on the concept of radiant comfort. And radiant comfort can be delivered through radiant ceilings, radiant walls, a combination of radiant floors and bathrooms, places where it's appropriate, etc. But if we as an industry are going to sell more of these systems, we've got to bring the cost down, because we're competing with a forced air distribution system out there that is dirt cheap. And we deliver a higher degree of comfort. So through the innovation of stuff like Dean's radiant panel ceiling system, it's bringing our installed costs down, which is going to equate to more sales, to more happy customers, etc. So it's all part of the big plan, as they say.
Are you still having in your systems a forced air system to circulate the air throughout the house, or are you using like an ERV to do that?
The correct answer to any question is it depends.
Exactly.
In Dean's case, he's using a centrally located fan coil unit that handles his dehumidification. So yes, you could use an ERV, you could use a DOAS, as he mentioned, to be able to handle that. So it has to be addressed. How you address it is up to you, and you have a number of options available to you. But if you don't address it, you're going to have a cold, muggy situation that isn't necessarily comfortable.
Well, surprisingly, this summer, I did not turn the dehumidification aspect on, which was just flicking a toggle switch on the air handler to let the fan coil and the air handler run, and to see what would happen to the humidity levels in the house, but still using the ERV as an independent standalone thing. And the humidity stayed in the upper 50s.
Perfect.
24/7. I mean, I didn't need to dehumidify, which was very surprising, pleasantly, quite frankly.
Yes.
And I still haven't figured out why, other than the not enough of humidity outside was able to migrate into the house.
Good bet.
I'm just, yeah. Anyway, well, I'm disappointed that there was just 3 of us listening to you today.
That's nothing. There'll be 300. There will be 300 that show up to watch this show later in our archives, so we're not too terribly worried about that.
Is that how it works?
Yes.
Everybody's out for happy hour now.
Yeah, they're all working.
Well, thank you guys. I appreciate it, and I learned, and hopefully I can replicate this in the coming years.
All right. Well, there's Dean's contact information on the screen now, so if you want to get a hold of Dean and
let me write that down.
Possibly incorporate anything that it is that he does in his systems into your design, including his Xlath.
On the panel on the right, it says Dean. I'm sorry, I've been calling you Dean with an M. Because
apparently I can't spell my own name.
Yeah, that's his new name.
Okay, let me write that down.
This is his stage name. Talbott.
Are you working with Dave directly, Springer?
Absolutely. Yeah, we've got a project in Stockton we're working on right now.
I think you mentioned it. I talked to him about a month ago. Say hi for me.
I will.
He's a radiant pioneer.
I know. I hooked up with him when talking to so many different people when I wanted to do radiant cooling and started doing my research back in 2009.
Yep.
And somebody in LA who was an engineer, I got his contact and he said, "You need to talk to Dave Springer, from Build America program." And I called him and we connected. He got the plans and said, "Yeah, let's do this."
Well, thank you for attending, Mike, and thank you for your questions, and thank you for your contributions to society as a contractor and somebody that's developing these things. Again, we would love for people to join the Radiant Professionals Alliance. We're of the members, by the members, for the members, with all the members benefiting. And especially thank you to Dean for our guests. And if you've already answered any questions, our next show that will be up next month will be with Water Furnace. And they have some new interesting products that have the ability to be able to generate water temperatures as high as 150 degrees, plus their whole little line of other products that they've got. So tune in next month. We'll be sending out some emails pretty soon and giving people notification of when, where, and how. And until then, thank you all very much and have yourselves a good evening.
Thank you.
And we will talk to you next month.
Okay. Bye now.
All right. Thanks, Mark.
You bet. Thank you, Dean.
Okay. Bye-bye.
Bye-bye.